I'm Leo Tani. You've seen me in such fine quality, epic chemistry educational videos such as Japanese spectrophotometers. Who needs them when we have a colorimeter? And is there really a difference in the color dye concentration in sports drinks? Part 2. Okay. The idea behind this lab, we are going to analyze, it's an investigating lab, we're analyzing the concentration of the blue color dye that they add in different drinks. Now in this case we're going to be doing Powerade, but for the purposes of this video, so you guys understand what's going on with the equipment, we're going to use green because I don't have the blue dye with me at this point. Now, there's some pieces of equipment you need to be familiar with. We have our LabQuest 2 here that's already connected to something called a colorimeter. Now, we do have a spectrophotometer. It's not acting the way that it should, so we can still get our data using the colorimeter as well. It's just not as fancy, but it will get the job done. Now, the thing about the colorimeter, on the inside, it opens up, and you might see, hey, there's a hole in there. Well, what you put in that hole is something called a cuvette. Now, in this case, this cuvette, I'm going to use that as the blank. It is, in fact, filled with rubbing alcohol because that's what I had at that time. And I'm going to go ahead and I'm going to put that directly in. Now, how you handle the cuvette, there's the side that has the ribs. You might be seeing the rib side here, and then you have the side that's perfectly clear. Now, if you look how the clear side is going through. You want to put the clear, where the clear side is going through, it's going this way, the clear side. Again, so you can see here that there's the rib side and the clear side. We're going to put that in like this. We're going to close it. Now the colorimeter is already at 635 nanometers, so that's the wavelength of light that we're kind of interested in. So we're going to press play, and then you notice that there's a red square and you have a keep button. Now the idea is this is an events with entry. So what we're going to do, we're going to press keep. And it's going to enter a value for the event. It doesn't matter what you give. You can give it a name, you can give it a number. It doesn't matter. I'm just going to call it number 1. And I'm going to press OK. Now you notice that you have a lab data. You have a data point there that talks about the absorbance. We'll get to that in a moment. Now I'm ready to go and test out 2 other cuvettes. One that is definitely very concentrated with green color dye, and the other is not as concentrated. So I'm going to remove this. And at this point, we're going under the assumption that everything's been calibrated and whatnot. So you can see I'm taking out this clear see-through cuvette. I am going to take the green cuvette here, and what you want to do, you want to make sure, again, you want the ribbed edges out this way. You want the clear edges going this way because that's the way the light is going through. It's really an LED, and what the machine is analyzing is how much of the light is being absorbed. Pretty cool, isn't it? So we're going to put that in. It's important that you close this because we want no outside light to interfere. Now, if you notice, we got our graph here. We're going to press keep again because we're going to take the data point, and in this case here I'm going to backtrack and I'm going to call it event number 2, and I'm going to press OK. OK. Now we're good for that. We're going to do one more. So again, we're going to take this out. We're going to remove the cuvette here. Now, if you notice, it's pretty thick. I mean, it was just 1 drop of green food coloring in a test tube full of rubbing alcohol. Now, we're going to use water and we're going to use blue food coloring. And what we're doing is we can create different concentrations of solutions that we can test out. Okay, and so we are going to be able to make a data table of known concentrations that we have control over. And what we're going to do, we're going to look at the data, and then we're going to be able to test the Powerade to see how much blue
dye is actually in there by concentration. Now, if you notice here, we have this one definitely much less concentrated. We're going to see what happens. And again, remember that ribbed side here. We're going to put that in here in our colorimeter. We're going to close this, and then we're going to hit the keep button again. This time I'm going to call it 3. Notice how difficult this is. And now I've got 3 data points. All right. Now, that's great. We're going to remove it. We have our data points. You guys are going to be doing several different data points. We have a couple of colorimeters, so I'm probably going to split the things among you guys. But remember, you want to keep this thing closed even when you're not using it. It will already be calibrated. Okay, and now let's go ahead, let's take a look and see what we have. We're done with data taking, so let's check our XY here and let's see what data we have come up with. Okay, so if you notice, we have events 1, 2, and 3 on here. Let's try to focus in a little bit on that. Okay, here we go. Okay, there's a certain minimum focusing distance. So we have events 1, 2, and 3. The first event was where we had no food coloring in. It was clear. And if you notice, we had a percent transmittance. You didn't see that. It automatically takes that in, which is great. So what is this percent transmittance? It's how much of the light has actually passed through. Now you'd say, but wait a minute. How in the world can it be 100.58% transmittance? Good question. I don't have an answer for that one, okay? But here's the thing, though. We have an absorbance of 0.00, which is kind of important because it didn't absorb anything, which is what we would expect. Now we went in, if you notice, we took the 2, the event number 2, and that's where we used the dark, more concentrated food coloring, and you notice that 1.08% of the light actually transmitted through. So that tells us something about the concentration. There's a lot of it. And if you look at the absorbance, it's 1.967. Okay, so there was a lot of absorbance of the light, and you may notice that there may be some kind of a relationship between the percent transmission and the absorbance. Okay, now let's take up the last one. The last one, we looked at it where it was not so colored, okay, it was less concentrated. That's event number 3. Notice we have a 56.62% transmittance. That means 56.62% of the light has gone through, okay, and over here for the absorbance, it's 0.247. Now, that's just it. Okay, we are expecting less absorbance. We see more transmittance here. Here we had, in number 1, we had 0 absorbance because there was no food coloring in there, and over 100% transmittance. So now what we're going to do, we're going to make different concentrations of the blue food dye. Okay, and I'll probably split you guys in groups on that because we have a pair of colorimeters for this. Then, once we gather our knowns, then we're going to test it against the blue Powerade, and let's find out if we can actually calculate the concentration of the blue coloring dye in the Powerade sports drink. This is an investigative lab. So I'm kind of interested, I am very much interested to see how this lab is going to turn out. All righty. So you have the basics. We're using a new piece of equipment. We are using the colorimeter, as you can see here, and we're going to be testing out the concentration of blue food dye, blue coloring dye in here, and that's basically the lab. I am Leo Tani, signing off.